Section 7.2 is on similar polygons. Two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. That means that they have the same shape but are not the same size. So the angles are going to be the same, but the sides are not going to be the same length. They're just going to be proportional. And we'll see what that looks like. So here we have quadrilateral ABCD and quadrilateral EFGH. And we use this single little squiggly, it's kind of like what we put on top of the congruent sign, to mean is similar to. So quadrilateral ABCD is similar to quadrilateral EFGH. Now, the order that we state those letters does matter. Actually, it doesn't matter for the first one. I can name my first quadrilateral however I want. So I can say ABCD, which kind of makes sense since that's an alphabetical order. But if they're going to correspond to each other, then A and E need to be in the same spot, B and F need to be in the same spot, C and G, and D and H. So, quadrilateral ABCD is similar to quadrilateral EFGH if and only if angle A is congruent to angle E. Maybe I'll go ahead and mark those. Angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D, this is getting a little sloppy here, is congruent to angle H. Notice they correspond to each other. A is the first letter mentioned here, E is the first letter mentioned here, so they are congruent to each other. And we need to say the sides are proportional. There's no way to mark this on the triangle, so we just have to write a proportion here with the ratios. So AB over EF, whatever number that ends up being. They're not equal to each other because AB in this case is longer than EF. AB divided by EF is the same as BC divided by FG, which is the same as CD divided by GH, which is the same as AD divided by EH. So this is what we mean by proportional. Notice the angles are congruent and the sides are proportional. Corresponding sides are proportional. So let's take a look at an example here. If triangle ABC is similar to triangle DEF, then list all of the pairs of congruent angles and write a proportion that relates the corresponding sides. So I know that triangle ABC is similar to triangle DEF. They're not congruent, they're not the same size, but they do have the same shape. Now, just looking at these two triangles doesn't look like they're the same shape because it looks like actually to get DEF kind of in the same orientation, I think we'd have to flip it and turn it. But we can also work off of this similarity statement right here. Since A is the first letter here and D is the first letter here, I can say that angle A is congruent to angle D. And you can actually mark that in the triangle if you think that's going to help. Continuing to work off of that, B is the middle one, E is the middle one, so angle B is congruent to angle E, and C and F are the last ones. Angle C is congruent to angle F. And let's just go ahead and mark those. B is congruent to E, and C is congruent to F. Okay, so that's the list of the pairs of congruent angles. Now I need to write a proportion that relates the corresponding sides. Might be a little hard to look at it in the diagram here since the one triangle is kind of flipped around, but I can actually even just work off of the letters in the similarity statement. So AB, which are the first two letters of the first one, over DE, so first two over first two, is equal to BC, so that's the second and the third, over EF, which is the second and the third. And then I need a third one, so I'm going to go with the first letter and the last letter, AC, and again the first letter and last letter, DF. So this is showing that these two triangles are similar to each other because all of their angles are congruent and their corresponding sides are proportional. And this would be the proportion showing the corresponding sides. Scale factor is the ratio of the lengths of corresponding sides. So in the previous example, let's go back up here, if the length of AB were 6 and the length of DE were 3, and because AB and DE are corresponding to each other, okay, then we could say that the scale factor of ABCD, because remember AB is 6 and DE is 3, so ABCD to DEF is going to be AB over DE, 6 over 3, reducing that 2 over 1, or usually with scale factor we write it like this with a colon, a ratio of 2 to 1. So what this is basically saying is that ABCD is twice as big as DEF. Now notice the order matters. If I said the scale factor of ABC to DEF, I'm going to do 6 to 3. And the scale factor of DEF, remember DE was 3 and AB was 6. In this case, it's going to be DE over AB, 3 over 6, 1 over 2, or 1 to 2. So the way they ask you for the scale factor matters. Which one to which one? Let's do an example here. Determine whether the pair of figures is similar. If so, write the similarity statement. In other words, say this triangle is similar to that triangle, and find the scale factor. If not, explain why they're not. Okay, let's take a look at the picture here. So angles are the easiest way to start. So angle A is 117, angle H is 117. Okay, so angle A is congruent to angle H. Angle B is 27, angle F is 27, so angle B is congruent to angle F, and angle C is 36 and angle J is 36. So angle C is congruent to angle J. So corresponding angles are congruent. Now, are corresponding sides congruent? Let's check that. So I know what AC is, and AC, since this is the first and the last, would correspond to HJ. So is AC over, let's see, AC over HJ equal to, let's do AB, and AB would correspond to HF, and is that equal to BC, and BC would correspond to FJ. In other words, are all of these fractions equal to each other? Well, let's see. So AC over HJ would be 6 over 3. So one more room here. AB over HF would be 8 over 4. And BC is 12, and FJ is 6. So are all of those fractions equal to each other? Indeed they are, because they all come out to be 2. Okay, so yes, these triangles are similar. Okay, so we have angles congruent, and the sides are proportional. Therefore, they are similar triangles. So let's write a similarity statement. Remember, it doesn't matter how I name the first triangle, but I do have to pay attention then to the way I name the second triangle. So I'm going to, for the first one, I'm just going to go with triangle ABC is similar to triangle. Now if I did ABC, I have to do HFJ, because angle A is congruent to angle H, B is congruent to F, and C is congruent to J. So that's my similarity statement. When it says write a similarity statement, that's what I'm looking for. Now find the scale factor. Now notice in this problem it didn't say the scale factor of this triangle to that triangle. So I generally, if they don't state it, I generally go from the one on the left to the one on the right. So the scale factor of triangle ABC to triangle HFJ is going to be basically any one of these here. AC over HJ, all of these proportions are the same. So that's going to be 2 to 1. So each of these fractions reduces to 2 over 1. So those are the two parts of my answer. Here we have pentagon ABCDE and pentagon RSTUV, and we need to find X and Y. Okay, we know that they're similar to each other, so I know that AB corresponds to RS. I know that ED corresponds to VU, and CD corresponds to TU. So I'll go ahead and write that out. So AB over RS is equal to ED over VU, which is equal to CD over TU. Notice one other thing, when I wrote my proportion, all of my letters on the top refer to the first pentagon, and all of my letters on the bottom refer to the second pentagon. Now, to make this a little simpler, I'm going to add in some numbers. So AB is 6, RS is 4, ED is 8, and VU is Y plus 1, CD is X, and TU is 3. Okay, so basically we have to find X and Y. And this is one kind of long proportion, but I can actually break it up into two different ones. So I can look at these two right here, okay, because that's going to give me a proportion I can do that has only Y in it. And it's a little sloppier here. I can make this one here. Can I do this? There we go. How about that? Okay, and then those two are going to be equal to each other. I'll go ahead and write that out so it looks a little better. So 6 over 4 is going to equal X over 3, and 6 over 4 is going to equal 8 over Y plus 1. Now we have some pretty straightforward proportions to solve. So 4X equals 18, or X is equal to 9 over 2, or you can write it as 4.5. I'll accept either one of those. And then doing the cross product here, 6 times Y plus 1 equals 32. 6Y plus 6 equals 32. 6Y equals 26, or Y is equal to 13 over 3. And I'm going to leave that like that since that's going to give me a repeating decimal. Okay, so just set up your proportion with corresponding sides to find the X and the Y. And here we have pentagon ABCDE and pentagon RSTUV. We need to find the scale factor and the perimeter of each polygon. Okay, so I'm going to go ahead and fill in, since I know that AE and ED are congruent, I'm going to make that a 4. I do know that AB and CD are congruent, but I don't know what that is. And BC is just 6. VR and VU are congruent, so that's a 7. UT and RS are congruent, so that's a 10.5. What I don't know, and maybe I'll go ahead and use some letters here, is I don't know what AB and CD are, and I don't know what ST is. So I can give those letters. Make sure they're different letters since they are different lengths. Okay, so I can go ahead and set up some proportions here. It's kind of nice that they line up and then one of them isn't twisted. So I can say 4 over 7, which is AE over RV, is equal to AB, which is X, over 10.5. And then I need to find what Y is, and that corresponds to BC, which is 6 over Y. Okay? So let's go ahead and solve each one of those. So I'll do this first one. So 7x is equal to, is that 42? So x is equal to 6. So let me go ahead and fill in what x was. So x was AB and CD. That's equal to 6. And then doing my other proportion, so I'm going to use this 4 over 7 and 6 over y. That gives me 4y equals 42, or y is equal to 10.5. Well, that's kind of crazy. So those sides are congruent to each other. So y corresponded to st. So st was 10.5. Okay? So to find the perimeter of each polygon, so the perimeter of pentagon ABCDE, and what did we figure out 6 is? Or x is equal to 6, so this is a 6, and this is a 6. And let me go ahead and do the other one too. This was a 10.5. So it's going to be 4 plus 4 plus 6 plus 6 plus 6, or 26. That perimeter of pentagon RSTUV is going to be 7 plus 7 plus 10.5. Actually, I could have written this as 10.5 times 3, but let's go ahead and add them all up. And that ends up being 45.5. Okay? And then we have to know the scale factor. So that's the perimeter of each polygon, 26 and 45.5. And it says find the scale factor. Scale factor is just going to be any two sides corresponding to each other. And since they didn't distinguish between which to which, which polygon, which pentagon to which pentagon, I'm going to go from the left to the right. So the scale factor is 7 to 4. And actually, this is kind of interesting. If you were to do 26 over 45.5, that is also going to give you 4 over 7. So the scale factor that uses the corresponding sides is also going to work when the perimeters correspond to each other. And I believe